Welcome to part 2 on the videos on velocity time graphs. In part 1, we explored the velocity and acceleration at different points throughout the motion. And in this video, we're going to explore the total distance and displacement traveled by the person throughout the motion. In questions 6 and 7, we're asked about the displacement and the distance traveled by the person. In both of these questions, we're looking at how far the person goes. To calculate distance and displacement on a velocity time graph, we're going to have to find the areas between our 0 meters per second line and our curve. We have 6 different areas, so let's define these quickly with different colors. We break the areas up according to shapes to make them easy to calculate. Area 1 here is a triangle from time 0 to 2 seconds. Area 2 is a rectangle from time 2 to 3 seconds. Area 3 is another triangle from time 3 to 4 seconds. Area 4 is a little bit tricky. It's this triangle here, but remember it breaks up at 5.5 seconds. So it's a triangle from time 4 to 5.5 seconds. Area number 5 is another rectangle from time 5.5 to 6 seconds. And finally, we have area number 6, which is another triangle from time 6 seconds to 8 seconds. We label these segments before calculating their areas. So here, the light blue segment is segment 1. The green segment is segment 2. The yellow segment is segment 3. The dark blue segment is segment 4. The orange segment is segment 5. And the pink segment is segment 6. The area of a triangle is equal to 1/2 base times height. The area of a rectangle is equal to width times length. So the easiest way to answer question 6 and 7 is just to find all our areas up front. So we'll start with segment 1 here. So segment 1 is a triangle, so we're using this first equation. So the area of segment 1 is equal to 1/2. Our base is 2 seconds. And our height is 2 meters per second. 2 meters per second. Our seconds on the top cancel with our seconds on the bottom. 1/2 times 2 is equal to 2. Our units that are remaining is meters. Our green area here is our second segment, and it's a rectangle, so we use this equation for the area of a rectangle. So for the second area, it's equal to our width, which is equal to 1 second, and our length, which is equal to 2 meters per second. Again, our seconds cancel out, and we're left with an area of 2 meters, because our meters remain. Our third area here is again a triangle, so our third area is equal to 1/2. We have a base of 1 second and a height of 2 meters per second. Our seconds cancel out, and we're left with an area of 1 meter. Our dark blue area here, our fourth area, is again a triangle, but we need to be a little bit careful because our base is still 1.5, but our height is now below the 0. So we actually have a height of -3. So if we calculate the area of this fourth shape, we end up with 1/2. Our base is 1.5 seconds, and our height is -3 meters per second. The seconds still cancel out, and this gives us an area equal to -2.25 meters. This negative is actually quite important. So in our first 3 areas, you'll see we had a positive velocity. So our displacement or our movement was in the positive direction. Here, when we slowed down, we actually came to a stop and we started moving in the negative direction. So this displacement or this distance traveled is in the negative direction or the opposite direction as these initial 3 movements. Our fifth area is this thin little orange rectangle, and we calculate the area of this rectangle. We have a width of 0.5 seconds, and we have a length of -3 meters per second. 0.5 multiplied by -3 is -1.5 meters. Our sixth and final area here is another triangle. So we calculate the area of this triangle and we get 1/2 multiplied by the base, which is 2 seconds, and the height, which is again -3 meters per second. Our seconds cancel out, and 1/2 times 2 times -3 is equal to -3 meters. We're now ready to answer our questions. So our questions look extremely similar. The only difference is in question 6, we're asked for the difference, and in question 7, we're asked for the displacement. So what question 6 and 7 are really asking is, do you know the difference between distance and displacement? So distance is how far we travel, irregardless of the direction we're going. Displacement is how far we end up from where we started. How far are you displaced from your starting point? So when we calculate the displacement, the direction we're traveling is very important. So to answer question 6, what is the total distance traveled by the person over the total motion? All we have to do here is add up our distances traveled. So in our first segment, the person goes 2 meters. In our second segment, they go another 2 meters. In our third segment, they go 1 meter. In our fourth segment, they go 2.25 meters. Remember, we're calculating distance traveled, so the direction doesn't matter. Regardless of what direction they walk this 2.25 meters, they walked it. In our fifth segment here, we went 1.5 meters, and in our sixth segment, we went 3 meters. This gives us a total distance traveled of 11.75 meters if we total all of these individual distances. For question 7, we calculate what is the person's total displacement over the motion. So for question 7, first they travel positive 2 meters or 2 meters in the positive direction. Then they travel another 2 meters in the positive direction in segment 2. In segment 3, which is our yellow segment here, they travel another 1 meter in the positive direction. Then we flip below the 0 line here. So now we're traveling in the negative direction. In segment 4, we're traveling 2.25 meters in the negative direction. 2.25 meters. In segment 5, we're traveling 1.5 meters in the negative direction. And in segment 6, we're traveling another 3 meters in the negative direction. So our total displacement, if we add up all of these displacement, gives us negative 1.75 meters. So the person ends up 1.75 meters to the negative of their starting position, if the positive direction is the direction they initially traveled here. If you look at these areas, it sort of makes sense because this area here on the top is slightly smaller than this area on the bottom, which is slightly bigger. So we expect a slight displacement in the negative direction. If you're still struggling with the fundamental difference between distance and displacement, just think of this easy example. Imagine the grocery store was 1 kilometer away from your house. So if somebody asked you, what distance did you walk to get to the grocery store and back to your house, you'd say, well, I walked 1 kilometer there and I walked 1 kilometer back for a total distance traveled of 2 kilometers. In physics, we're often concerned with displacement, and this is how far you end up from where you started. So if you walk 1 kilometer to the grocery store and then 1 kilometer back to your house, you have 0 displacement because you're exactly where you started. Thank you for watching the videos on velocity time graphs, where we explored the velocity, acceleration, distance, and displacement of a person throughout the motion.